Hi everyone, today I'm going to walk you through this comprehensive web development concept map that I created. This map represents everything we have learned in this course and it shows all these technologies and concept maps that connect together to create a modern web application. At the very center, we have the web development. This is our main topic. From here, I've organized everything into three major branches. On the left, we have the front-end fundamentals, where everything the user sees and interacts with in their browser. And on the right, we have the fundamentals of backend and the architecture, the uh, the server-side logics and the database that power our application. And at the very bottom, we have the architectural patterns, the different ways we can structure a complete web application. So now let's start exploring the branches in detail, beginning with the front end fundamentals. So first we have the HTML, mm, which stands for Hypertext Markup Language. The HTML is the structure for a web page. Think of it as a skeleton or a foundation in which we have semantic tags. We use semantic tags like headers, nav, sections, like articles and footer. So these tags give us meaning to the content and help with accessibility and the SEOs in the pages. Then we have DOM, which is the document object model. This is a tree-like representation of our HTML that the JavaScript can manipulate, and we can add elements, remove them, or change their content, and all this is done dynamically. And we have the box model. In every HTML element is essentially a box with content, padding, border, and margins. These are used for understanding, and this is crucial for a layout. And moving on to the CSS, CSS stands for Cascading Style Sheets, while HTML gives us the structure. CSS gives us the styling, like the colors, fonts, layouts, and animation. Everything that makes the web page beautiful is from CSS. And first, we have the selectors to target elements. Um, so the class selectors like buttons, ID selectors like header, and the complex selectors like parent to child to select specific style elements. And for properties we have uh, uh, like we apply colors such as say color blue and a font size 16 pixel. And there is a display where we use like a flex or a grid box, and there are hundreds of CSS properties we can use. And moving on to the Bootstrap. So many developers use Bootstrap as a CSS framework that provides a pre-built responsive components. It speeds up the development significantly. And we have the JavaScript, which uses we use ESX modules. And now the most powerful part of the front end. This is what brings our page to life. This is interactive layer. We use modern variable declarations, let for variables that change, um, and const for constants. We never use var anymore because it is outdated and has scoping issues. And we use function blocks that are used for building blocks of our code. We write them using the arrow function syntax, like const my function equal to the arrow function. Inside we write a code which is much clean and um, handles better with this, like better than the traditional functions. One of the most important concepts is async wait and promises. JavaScript is a single threaded, but we often use and need to wait for things like fetching a data from an API or reading a file. This is where promises comes in. Promises let us handle all these asynchronous operations and asynchronous wait, makes the syntax is much cleaner and easier to read. The ESX modules we use help us organize our code instead of having everything in a one giant file. We can split our code into modules and use import to bring in what we need and what we need to export to share our code with other files. And the array method boxes, uh, so in array methods we use something like map, filter, and reduce, which are incredible and powerful. So instead of writing loops of code everywhere, and this is where the array method comes in hand. We use functional programming methods to transform and manipulate data in a clean and a declarative way. So for closures, the functional JavaScript are advanced concepts, and a closure is when a function remembers variables from its outer scope. The fundamental is how JavaScript works and enables powerful patterns like private variables and callbacks. So moving on to Ajax and developer tools. So the asynchronous JavaScript and XML, although we rarely use XML anymore, we can use fetch API to make a request, HTTP request from the browser to the servers. This lets us load data with refreshing the entire page, and that's how modern web, like single page applications work. And moving on to the developer tools, um, we have developer tools like ESLint, which checks our code for errors and enforces coding standards like Prettier, which automatically formats our code to look consistent. And these tools are essential for maintaining code quality, especially when working in teams. That's the complete front end. Now let's jump to the back end. So here, the backend is where the server, the part of users don't see, but which are absolutely critical. This is where we handle business logics, the authentications, the database operations, and more. We use Node.js with Express. Node.js lets us run JavaScript on the server, but not on the browser. So Express is a minimal web framework that makes building server much easier. So let's start with the routing, which is how we define what happens when a user visits a different URL. We write routes like app.get to handle get requests to the user's endpoint, or the app.post to handle the login submissions. So in the middleware are the functions that process requests for before they reach our router handles. So in these middlewares, they can do things like authentication, logging, passing request bodies. They have access to request objects, response objects, and the functions to pass control. And we use app.listen to start our server on a specific port like 3000 or 8080. We use 4000, so it can start accepting requests from other clients. So let's talk about HTTP. So HTTP is abbreviates to Hypertext Transfer Protocol. This is the protocol that powers the web, how browser and server communicate. HTTP is a request response protocol. The client sends a request and the server processes it, and it brings back a response. The methods, we have different HTTP methods for different operations. Get is for retrieving data, like loading a web page or getting a list of users, and post is for creating new data. like submitting a form or creating a new user account. So put is for updating existing data, like editing your profile or um, editing which needs to be made a change, and delete is for removing data, like deleting a post. So for every response, there is a status code. So status code means um, well, we have a lot of status codes like 200, 404, and 500, which means 200 means success, everything worked perfectly fine, and 400 means the page has not been found, or the request we made was not found or does not exist, and 500 means it has a server error, that something went wrong on the server side. And there are many more status codes like these, but these are the common ones. So now let's talk about the MongoDB. So MongoDB is our NoSQL database. Unlike the traditional SQL databases with tables, rows, MongoDB it stores data in a flexible JSON like documents. So this makes it perfect for JavaScript applications. So MongoDB is a ODM, which means Object Data Modeling Library. It provides us a schema based solution for MongoDB. Uh, we can define schemas like enforce structures on documents, validate data, create relationship between different types of data. So it makes working with the MongoDB much easier and safer. And there are operations like CRUD, which is very essential for a database, where we use create, which is essentially adding new documents to our database, and read is for finding and retrieving a document. Update is like modifying an existing document. Delete is to remove the documents. So these are the fundamental operations for any data-driven application. Moving on to the queries. So queries are done in something called MQL, which is the MongoDB query language. We can find documents based on criteria like find all users with age greater than 18, or find products stored by price. MongoDB's query language is very powerful and flexible. For more complex operations, we use the aggregation pipeline. This let us chain together multiple operations like filtering, grouping, sorting, calculating averages, for example, to transform our data is in a very sophisticated way. Think of it like a data processing pipeline. Mm, Now moving on to the Atlas. So Atlas, we use it in deployment. We typically use Atlas for deployment. The MongoDB cloud hosts a service. It handles all the infrastructure for us, or we can run MongoDB locally on our development machine for testing. That completely changes the backend. And now let's look at how all these things are put together. So let's move on to the architecture. So here we have different ways of architectures where we structure our complete web applications. So mainly there are three main approaches. The simplest is the static sites, which means this only runs on this a browser. So there is no backend or database, and in this we use only the browser, where the user downloads the HTML, CSS, and JavaScript and runs everything locally. We use vanilla JS, a pure JavaScript without any backend framework. This is perfect for simple projects, portfolios, landing pages, or documentation sites. It's fast, simple, and easy to deploy. And moving on to the three-tier full stack box. So the most common and powerful pattern is a three-tier full stack. So this is what most of the modern web application use. Something like Netflix, Facebook, Twitter, They all follow this pattern. Three tier means we have three separate layers. Each of it has its own responsibility. This separation makes our application maintainable, scalable, and easier to debug. The first tier is the presentation layer. So this is everything we have talked about in the front end, the HTML, CSS, JavaScript that runs in a client browser. This is what a user sees and interacts it with. So it displays the data to the user and captures the input. So the second tier is the application layer. So in this, the backend server, like our Node.js and Express code runs. This is where the business logic lives. It processes the request from a presentation layer, enforces to the business rules, handles authentications, validates the data, then communicates it with the database. It is practically a brain for our application. And the third tier, which is the data layer, we use Mongo here. So MongoDB is our case where all our information is stored persistently, and user data, posts, products, orders, everything that gets saved here. The application layer is the only thing that talks directly to the database. So the presentation layer never accesses the database directly. This is the best security practices known to the uh, web development people. So here is how everything work together. A user clicks a button on the presentation layer, which sends an HTTP request to the application layer. The application layer processes that request and maybe the queries the data layer for all the information and sends back a response to the presentation layer, which updates the UI. This is the complete flow. The architecture is called as the three tier because it has three layers and actually runs on three different machines: your browser on the laptop, the application server on the data center, and the database on the server. This separation gives us incredibly flexible and a very scalable platform for us. And moving on to the client server box. So the third pattern is the client server communication. This describes how the front end and the back end talk to each other. Mm, so REST API, we build REST APIs to represent state transfer. Um, for example, we create endpoints for specific URLs that a client can call. For example, get API users might return all these posts, and the API users might create a new user. REST is an architectural style that uses a standard HTTP method, and it is stateless, which means each request contains all the information needed to process it. We use JSON, JavaScript object notation, as our I think it's our data format, and JSON is perfect because it is lightweight, it's human readable, and the JavaScript can work with it natively. So when we use the server, it sends a data to the client, and it is formatted as JSON. When the client sends the data to the server, it is also JSON. So put it all together, we see a complete picture where user imagines what he wants with a list of products on an e-commerce site, and when they open the browser, that's the presentation layer. The JavaScript code in the browser fetches the request. So this is where the request goes over the HTTP and the Node Express server and the application layer. So the server receives the GET request to API. The server queries the MongoDB, returns the data. The server formats it as the JSON and sends it back to the HTTP. So from the HTTP, the browser receives this JSON response, and the JavaScript updates the DOM to display the products to the user, and that's the complete journey of the front end technologies which we use, and backend handling the logics and databases operations, following a clear architectural pattern with communicating via JSON and HTTP. For every single box, this map plays a crucial role in this flow. So we have the front end for HTML, CSS, JavaScript for interactivity. Then we have the Ajax for making requests, and we have Mongo for data persistence. We saw the three-tier full stack application which we normally use, and JavaScript which works on the both sides, front end and the back end, where so the JavaScript works on the browser in front end and Node.js at the back end. This is powerful, and this one language which we use for everything. And backend uses Mongo to connect to the MongoDB server, and it sends queries and gets back the data. And uh, I think this is the entire map that we follow, and the things we have learned in class. And what I love about this map is that it shows both individual pieces and how they all fit together. Each technology has its purpose. Each pattern solves specific problems, and when you combine all them, you can build anything on web. As you continue this web development, keep this the big picture in mind, and when you are trying to write a CSS, remember the part of the presentation layer, and everything connects and everything has a purpose in this. And now I think we have a clear picture and able to understand the uh, objective of web development. So that's it. Thank you for watching. I hope this map helps you. Let's have a live coding about the front end development, which would make us easier to understand. All right, let's do some live coding. I'm going to build a simple interactive task manager from scratch to demonstrate the key concepts we have discussed using HTML structure, CSS styling, and JavaScript ESX interactivity. Let's start. First, let's create a HTML structure. This is the skeleton of our application. I've copied the code, and notice I'm using the semantic HTML, the container div, and import for the user entry, a buttons to add tasks, and unordered list where our task will appear. I'm linking to our CSS and JavaScript files at the bottom. And let me demonstrate how this HTML works. And yeah, so this is our basic HTML site where we can see the h1 tag, my task manager, and the button. And now let's build the CSS part. Let's add some styling to make this look more professional. So I've already copied my CSS code from Claude, and I'm using a modern CSS flexbox for layout, gradients for a background, and border radius for round corners and for transitions. And for smooth animations, notice however the hover effects on the button and the task items. So, and the colors I've given for each and everything very specific, and the buttons have a different color as well, which is white. And let's see how this works. Yeah, yeah. This is how our CSS styles our page, and here we have different colors for the button and the text, and we have a background as well. Um, Moving on to the JavaScript, and this is where the magic happens, where the JavaScript ESX to make this much interactive. Hmm? And again, I've already written this code, and for this video purpose, let me break down what's happening here. So let's start with building our JavaScript. Yeah, I'm gonna create a file, script.js for the JavaScript. First, I'm gonna create, yeah, script.js in the same file location as the index and the CSS, and paste my copied code from the cloud. And let me break down what's happening here. First, I'm selecting the DOM elements using the get element by ID. Then I'm storing task in an array. This is our data structure. The add task function uses an arrow function, that is ESX syntax. It validates an input and creates task objects with unique ID using date.now, and it adds to our array, which re-renders the list. And render task use for each array method a functional programming approach using templates literals. And toggle task use the map method to spread operator, which is more ESX features. And the delete task uses the filter method to remove a task from the array. And finally, the event listeners for one button click, and one for the enter key. And this is how we handle interactions. So let me just demonstrate it. So when I type here learn HTML and add click, it adds a task. And let's add another task, master CSS. Let's add another one, JavaScript ESX. Well, we can see that the tasks are uh, arranged below, and let's try to delete task and see if it's properly deleting. Look at that. I can add task and mark them as complete. Once I can delete task as well. Everything works smoothly with animations. And thank you for watching. Have a nice day.